So today we are going to be talking about trig graphs, and trig graphs are very related to trig equations that we were learning about in the last lesson. So if we look at the basic trig graph, and let's make sure everyone can see, I'll make this nice and big so there's no ambiguity. There's three main trig graphs that we deal with. Okay, so we deal with the sine graph, and what we say is the period of the basic sine graph is 360 degrees. So it takes 360 degrees to go, here are the four quadrants, to go up, down, and then up. That's a full sine graph, and it's 360 degrees, okay? Then we can say that the cos graph also has a period of 360. It just has a slightly different shape. It actually starts at 1 if we start at 0 and keeps going like that. And then the tan graph has a period of 180 degrees. So in fact, let me rather show you a full one like this. If we go from 90 to 270, that's a full tan graph. So that's an important difference. The other thing that is important is that we know what the range of the graphs, the basic range of the graphs are. So if we look at range for the basic sine graph, it's the highest point is 1, the lowest point is -1. And we notice that they're symmetrical across the halfway point. The same range is true for the cos graph, but the tan graph, actually, its range is infinite in the positive direction and infinite in the negative direction. Yeah, and now when we take these basic trig graphs, we can remix them. We call them changes, parameter changes, or shifts. Who can tell me some of the basic, or who can tell me the changes that we need to be comfortable with for trig graphs that you remember from class? And you can raise your hand or you can put them in the chat. What are some of the changes we need to be comfortable working with moving? This is more sort of grade 10 going into grade 11. In grade 11, we learn about shifts and transformations. So I want to see what you remember. What are the different shifts that we need to know about, or changes? You can put it in the chat. As a group, I'm sure we can get them all. We can start from simplest to hardest if you want. So what's the first one going to be? What's the easiest change that we can make to trig graphs? If we think of having the simple graphs of y equals sine x, y equals cos x, y equals tan x. I'll even put a bracket around these. Normally, the simplest change that I think of, let's call this 0. The simplest change is just a vertical shift. So if I want, I can make y equals sine x move down by 1 unit. I could make the cos graph move up by 1 unit. Or I could make the tan graph move up by 2 units. And often this is referred to as Q, and that's called a vertical shift. It basically would just move. So if we took sine x minus 1, if we wanted to see what that graph looked like, so I'm going to focus on this one here, it would just be this whole graph moved down by 1. So I would get, let me see if I can draw it in, to there, to there. Okay, I need some extra space here, and then it would be up to here. Give me a thumbs up if you understand what a vertical shift is. Give me a thumbs down if you don't know what a vertical shift is. Okay, so that's the one thing that you need to be aware of for today's graphs is the vertical shift. Now, I want to ask you, if we have to compare these two, I'm looking at the sine graph at the moment. Now, I drew in this red one over here, but before we do that, the original sine graph, so let's say the original sine graph, which is here, its range is between -1 and 1. But I shifted the original graph down and I drew the red one. can you tell me what the range is for the shifted graph that's been shifted down? So I'm basically focusing on the sine x minus 1. What is going to be the range of the shifted graph that I've just drawn in here? And I want you to try and put that in the chat. You can see the highest point it gets to is 0. What's the lowest point it's going to get to going to be? Oh, wait, I should actually be the other way around. Sorry, because -2 is lower here. So it would be -2 to 0. Okay, cool. So we're going to initially focus on that, but there are some other changes that we're going to deal with later on. And I just want to highlight them before I start, but not as much detail. What type of change happens if I put a number in front of the sine graph? So now I'm imagining a graph where I'm going to take my red one away because that is not that important right now. What do you think is going to happen if I put a 2 in front of the sine x? What type of trig graph change is that? You put your hand up to let me know, or you can put it in the chat. I'm going to draw this graph in a moment. It's a normal sine graph, except it's had a 2 in front. And I'm going to extend my axes so that I have a -2, and then I also have a 2 up here. It's not a horizontal shift, Peter. What this is called, it's called an amplitude change. And it changes the amplitude from 1, which it normally is, to 2. So when you draw this graph, okay, what's going to happen is you start normally, but instead of going up to 1, you have to go up to 2. And then when you come down to 0, and then you have to go down to -2, and then you go up. So it's almost like you're vertically stretching the graph. So the blue one is what this graph will look like, and it's called an amplitude change, and it stretches the graph up or down. Now, I want to know, what is the range of this new shifted graph, y equals 2 sine x, if you look at the drawing? Yeah, Kiara, you're right. It doesn't just stretch it upwards. It can actually compress the graph too. If there was a half in front, it would have stretched, it would have compressed it. Yeah. But what do we think the range is for that blue graph that I just drew there? And it's not a perfect graph because I'm drawing it freehand. That's the lowest point there. Make sure we have our important points here. So the lowest point it gets to is -2. The highest point it gets to is 2. And another way of writing this, if you like, you could have also written it in this notation, where you say y is in the middle and it's between -2 and 2. And what I want you to notice is that the period of the graph hasn't changed. It still takes 360 degrees to go through the whole thing, but it just goes higher and lower. Now, those are the two most common transformations you have to be comfortable with. The other ones are period change and horizontal shift, but I'll come to that later in the lesson. So give me a thumbs up if you're with me so far. Give me a thumbs down if you're feeling a bit lost. I want to start with some simple multiple choice questions to get a feel for how we're doing. Okay, let's rock and roll. So step number 1, you're going to have to help me vote here. What type of graph, trig graph, is this? what type of trig graph is this? Is it A, B, C, or D? So I see the answers are coming in thick and fast. And the thing that is really important to recognize is that this graph is starting at 1, going down to 90. So it's not going to be the sine graph. It's definitely not the tan graph. It's not that. So the answer must be B. Cos, and you can kind of see how, because it drops down first. Another thing to notice actually is, notice how this graph is positive between 0 and 90. It's then negative, negative, and then over here it's positive. Now, if you think of that shape, if you think about that, cos is positive in quadrant 1 and positive in quadrant 4. And so the cos diagram can also help you a little bit in seeing that pattern. Okay, let's do another one. Let's do this one. What type of trig graph is this? Is it A, B, C, or D? Okay, everyone is getting this super, super quick. And so this is a tan graph. And the reason I think we got it so quickly is the tan graph looks funky and it's got these dotted lines. Who can tell me, what are these dotted lines here? What do they represent? Because everyone recognizes the tan. It's almost like this guy who's bending over backwards, or, you know, one of these arm things that kind of wave in the wind. So these are called asymptotes, and they are places where it's undefined and the graphs may not cross. And you notice there's an asymptote every 180 degrees. And the reason they come every 180 is that the period of the tan graph is 180. So everything repeats itself every 180. So whenever you see these asymptotes, you know that probably tan is involved. Okay, now I want you to identify the equation that goes with this curve. What is the equation of this curve? Can you match it? So we're looking and we're seeing this is probably in line with 90, and this is probably in line with 270. So the period is 360. It's definitely not tan. That's a hyperbola. So it's either these two. And we know that cos starts at 1. So it must be A. Okay, you're doing very nicely. So I think we can take it up a notch. Let's do some transformations. So what effect does the transformation y equals sine x plus 3 have on the graph of the function y equals sine x? Take a moment to think about that, and then you can tell me what your answer is. What does this plus 3 do? I think this is a vertical shift. So it's not going to be this or this. It's just a question of, is it A or B? And the plus 3 is going to move it up. So B is the correct answer. Yeah, actually, nicely done. Isaiah, nicely done. Okay, now let's do this one. What effect does the transformation minus cos x have on the graph? So there's a -1 in front of the cos x graph. Now, I want you to think a bit more about this one and think through what a normal cos graph looks like, And then I want you to think about what maybe happens when there's a minus in front. So a normal cos graph will probably look something like that. But now there's this minus in front. So whenever this was a positive one, that's going to become a minus one because it's going from positive to negative here. The 0 is going to stay the same. This one was a minus 1. It's going to become a positive 1. This will stay the same, and this will go down to here. And so that is what the new graph will look like. And what we can see is that it's reflected over the x-axis. Another way, yeah, so this is going to be reflected over the x-axis because the minus is going to just flip everything over the thing like that. Now, that's probably the trickiest one we've done. But are there any questions or comments about that before I move on? I don't want to go quite as fast as I have been going for the other ones. Okay, so that's called a reflection. And generally speaking, if you imagine multiplying both sides by -1, another way of writing what they have there is like this. And my rule of thumb is if you change the sign in front of the y, it is going to reflect over the opposite axis. So what's the opposite of y? It's going to be x. So if you did that, you reflect over the x-axis, and this is exactly the same as that one. However, if you got something like this, what would that, now this is not very common, but what do you think this would reflect over? The cos of minus x. If you imagine the cos of minus x, if you did that, it would reflect over the y-axis. Okay, so that would just reflect over y-axis. And that's just whenever you're reflecting, whenever you do this, you just think, what variable am I changing? And it's going to be the opposite. Okay, that was just a bonus one I was throwing in. Okay, let's do another one. So, which of the following points does not lie on the graph of y equals sine x? You want to think about what does the sine graph look like and which of these won't fit. So let's say that's. So 0, 0 is all good. 190 doesn't, 180, 0 is fine. 270 minus 1 is fine. The only one that doesn't work to me is 190, because this should actually be 91. So 90 for x, and then across over here. So for me, it's a bit of a tricky one, but that is the one that does not lie on the graph. Like, see, I caught quite a few of you with that one. Give me a thumbs up if you understand now why the answer is A. It is sneaky, y'all. I'm turning up the heat now. So the warm-up stage of the lesson is concluding, and we're now starting to go into the next part. Okay, let's look at this one. What is the value of the cos of minus 60 if you look at this graph? So can you find, without a calculator, what is the value of the cos of minus 60 if you just look at this graph? Where is minus 60? I suppose 22. I feel like it's going to be here somewhere, because this is 22, that's 45, or minus 45. I don't think it can be this one. And I don't, if I look at this graph here, if you look at the y value, that if you imagine this being minus 60, right? So that's minus 60. Can you see that it ends up being a positive? It's positive on the y-axis. So I'm going to cross out these two. Now, my only options are half and root 3 over 2. Now, if we look at this over here, okay, maybe we should just use our calculators just to check for sure. So cos minus 60, it is, yeah, it's going to be a half. And you can see that, okay, my scale isn't perfect, but you can see that that is going to be A. Yeah, cool. Okay, so we're getting there with that one. Let's see, we're almost done with, okay, let's just do this one. And then we're going to take a break. Which of the following below gives the equation of the graph below? Which of the following? So a normal sine graph would look like that, if I remember it correctly. So what has happened? It feels like everything has moved down by a certain amount. So that's the normal one, and this has moved down to be the green one. Which of the options do you think is going to be correct here? Well, it can't be this one, because that's affecting the, can't be, it's either this one or this one. It's either A or D. And for me, it's moved downwards. So the correct answer should be A. Yeah. And I see Isaiah and Keisha agree with me. Thumbs up if you understood how that one worked. Thumbs down if you didn't understand. I think I want to squeeze in one more question if I can find one. And then after the break, we're going to look at past papers. But let's have a look. Let us. Okay, let's just do number one. I'll zoom in for number one. So, last one before the break. The graph of y equals tan theta on the domain 0 to 360 is not defined for which of the two options? Is it A, B, C, D, or E? If you think of the tan graph, where is it not defined? Another way of saying it is maybe where are those dotted lines or the asymptotes? Okay, so the correct option would be 90 and 270. That is where we have the asymptotes for the tan graph. Okay, everyone, let us take a break. So if you could turn your cameras on if they're not on already, and I want you to stand up with me. We've been going for a solid half an hour, and after the break, we are going to look at some past exam paper questions. So let's make sure we're relaxed. We're going to take some deep breaths. One more deep breath. Okay, then just shake out your arms. And the whole idea behind this is we're just getting some oxygen and some blood into our body so we learn effectively. So I'm shaking out my legs and I'm just loosening my body up because it's been sitting for half an hour and so it's kind of going to sleep. Okay, let's start with some circles. Some small circles. And then we're going into some big circles. And then we're changing direction, big circles into small circles. Okay, shake it out one more time. You want to be nice and loose and relaxed. We're going to start with twisting a little bit. So slow rotation each way. And as we relax, we are feeling like we can go further. Oh, that feels good. Okay, then let's do some triceps. So stretch out those triceps. Just hold. And then switch to the other arm. Yeah. Then let's just do some heart rate raising stuff. We're just going to do air skipping. And we're just going to do 20. I'm going to start in 3, 2, 1. Let's go. Three, two, one, and go. All right. So I hope that your body feels like it's had some circulation of oxygen and blood, and you are ready to roll for the second half of the lesson. Just before we move on, can you solve any of these Maths 24 puzzles for me? You have to make 24 using 4 numbers and only those 4 numbers. Okay. Can you make 24 using either of these values here? This is a 6. Let's just do the red one. We don't have to do the other one. We're just going to do the... Can we make 24 using these values? I'll give you a hint. If I go 6 divided by 3, what do I get? So 6 divided by 3, I should get 2. And I've used up those two numbers, but now I still have to get the 4, the 8, and the 2 to make 24. Who can get to 24? Anyone have any ideas? Otherwise, hey, Mbali has said 8 minus 6 is 2, and then 2 times 4 times 3. Mbali did it a different way, and you're absolutely correct, Mbali. That is completely perfect. Nkosi did the same thing. That is impressive. So you guys actually found your own way. Well done. Well done. Okay. And yellow. Oh, Mbasa has got the yellow one. 2 plus 5. Yeah, that's well done. So for the yellow one, which wasn't even on the menu, but 2 plus 5 over 5 is 3. And then 3 times 8 would give me 24. Okay, cool. Let's go back to what we were doing. I want to ask you about, this is a different type of question. And maybe I should just teach you how to do this, just in case, can you notice the number in front here it's not stuck on the end, it's not in front. What does this number over here do to the normal period, or to the graph? What type of change is that? Who knows what type of change that is? It's not a vertical shift. It's not an amplitude change. What else have you learned about this here that maybe that half is doing? I think that this is changing the period of the graph. So what is the period, the normal period of the sine graph? So I'm just going to say normal. First, tell me what the normal period of the sine graph is. So the normal period is what? It's 360. Yes. So if a graph has a new period, this number over here changes the period. So you take the normal one, or the old one, and you divide it by the number that's here. And that gives us the new period of the graph. So what is 360 divided by a half? What's that going to give you? Mbasa, let's unmute Mbasa. Can you hear me, Mbasa? Okay, I don't know if maybe that was a quick hand, but I'm seeing in the chat most of you are saying 720, and so you are correct. The answer, the new period of the graph, is 720. And just to show you what this looks like, what that means is that for this sine graph, instead of it going, say for example, we're very used to like 90, 180. Actually, that's going to take too long. But basically what happens is the normal sine graph will look like this. Okay. If you halve the period, what's going to happen is that it's then going to look like so there, and there. So for a whole sine graph, it's now going to take 720, whereas in the past, it used to only take 360. And so that's what a change of period looks like. So a question has been asked, what about the other functions? Also, maybe I should give you a made-up question myself here now, just to kind of get this really kind of in your head type of thing. Okay, if I said to you, I'm going to change the question, I'm going to say to you, it is now y equals cos 2x. Which of these 5 options would be the period of this graph, y equals cos 2x, when you notice that the number in front of the x is now a 2? So in course, we're going to practice what you're asking about now. So the normal period of the cos graph is 360, but I need to divide by the number in front of the x, which is 180. And so the correct answer is D. So the period of this cos graph will be 180. So it will do a full cycle in 180 degrees. If you imagine the cos graph normally starts here, but now that whole thing is going to complete within 180 degrees, which is going to make this 45, 90, 135, 180. It's like it's just been shloop together. Let's do one more before I move on. What is the period going to be of y equals tan a half x? So what is the period going to be of tan a half x? And you need to choose from those 5 options there. So the normal period of the tan graph is 180. And I divide by a half, which then gives me 360. And so the correct option would be B. And so a whole tan graph fits into 360 degrees. Cool. Okay, so we've covered now period change. We've covered amplitude change. Let's have a look at something. I like this question. Actually, no, that's a little bit too complicated for us right now. Let's go to an old exam question. Okay. So here is an old exam question. And just to kind of highlight what's going on in this, in the diagram, the graph of f of x is cos x is over here. Okay. The graph, oh, that's got a, okay. This, we haven't dealt with this type of change, but I'm going to talk about it now. What type of change is happening over here when we say g of x equals sine x plus b? That is not an amplitude change. It's not period change. It's not a vertical shift. It's something else. What is the type of change? What does this plus b do to the graph? Because the first question is to say, what is the value of b? What is the one type of change we haven't dealt with? Okay, so Malcolm has nailed it. This is what's called a horizontal shift. So this shifts the graph left or right. Now, what is tricky about the horizontal shift is that it shifts the opposite direction to what we would normally expect. So if there's a plus there, we would expect it to go to the right, but it's going to go to the left. And if there's a minus there, you would expect it to go to the left and it would go to the right. Now, I'm going to help you do this one. Let's look at the green graph. We know the green graph is a sine graph. We would expect the sine graph to start here, okay? But it looks like it's been shifted to go there. what type of shift has happened here? Can you see what I mean? Like normally you would expect the sine graph to start here and then go like, oh, it's not the best drawing, but it feels like that point has been moved. It's a horizontal shift. How much has it been horizontal? It's not a stretch. It looks like it's been shifted to the left by how much? Okay, now it's been shifted to the left by 30. And so what the value of the B is going to be is it's going to be plus 30. Now, the weird thing is plus 30 moves it to the left, which some students find strange because normally when you think of plus 30, you would think going to the right, but the horizontal shift is the one that works the other way around. And it's something that you just kind of have to learn. So the answer here would be B would be 30 because it's going 30 degrees to the left, and that would mean it's a plus 30 here. So I know that that's a little bit tricky. So maybe I should just make up another question just to illustrate this example. If I said to you, there was another function, let's call it h of x, and this function had the value x plus 40. What is that plus 40 doing to the normal cos graph based on what I've just shown you? Tell me in the chat what that plus 40 does to a normal cos graph. So all the plus 40 is going to do is it's going to move this 40 degrees to the left. So this whole graph would just move 40 degrees to the left here. Okay. So you all understand the basics of what a horizontal shift is. So let's go see what else we can do in this question. So I want you to write down the period of G. What is the period of G, which is the green graph? So what is G? It's a sine graph. And has the period been changed? No. So what is the normal period of a sine graph? It's 360 degrees. Okay, so we've done those two. I'm going to come back to 6.3 and 6.4. But before I get to those, I want to look at 6.5. So 6.5 says the graph of H is obtained by shifting F 3 units upwards. So F at the moment is f of x equals cos x. I want you to write down what you think the equation is for the h of x, which is obtained from f. What do you think I need to do to get an equation that shifts f 3 units upwards? We know what f is. F is just that. But I want to shift it up by 3 units. What do I need to do? You are so right, Ayanda. You are so right. You just go plus 3. So give me a thumbs up if you can see what Ayanda is saying, that you just add a plus 3 to shift it 3 units up. Now, the second part of the question is determine the range of H. Now, the normal cos graph, okay, has a range, and you can even see it here in the thing here. The range for the normal cos graph, the yellow graph, is between -1 and 1. What is the range going to be of h if you shift the graph up by 3 units? So normally it's between -1 and 1 for the range, but now you've shifted it up by 3. What's going to be my new range based on this transformation that you have just done? Okay, Bossy, be careful. This is not an amplitude change. This literally moves the whole thing up by 3. It simply moves it up by 3. So if you move the whole thing up by 3, your lowest value is now going to be 2. Because if you imagine -1 plus 3, you get 2. What's the highest value that this new function is going to get to? So the highest value it's going to get to is going to be 4. Yeah. So that's a 2-mark question. It's 1 mark for recognizing the type of change, and it's another mark for saying what the range is over here. Thumbs up if you got that tricky bit. Thumbs down if you don't feel like you understand that sneaky bit. Because the amplitude change will make it bigger in both directions. But when you shift up, it only simply moves everything up by a set amount. It doesn't actually stretch anything. Yeah, fantastic. So now let's have a look at 6.3. 6.3 says, write down the values of x in the interval -180 to 90. Now, that's just the playground over here. Now, at the moment, this looks really tricky, but there's one sneaky trick that you can use, is you can rewrite this as where do the two graphs equal each other? Now, f of x minus g of x is the same as writing f of x equal to g of x. So identify for me on the x-axis, where are the two places where the two graphs, the yellow and the green graph, are equal to each other? Where on your drawing is, because f of x equal to g of x, where are those equal to each other? So I'm looking and I see they collide over here. And so I'm going to drop down, and one of my answers is going to be 30. Where's the other one going to be? Well, there's a collision point over here, and that collision point is -150. Yeah, so the two places, so write down the values of x. They're just saying, values of x. And I should say when x is 30, let me write it out fully properly. And x is equal to -150. So this just says in the interval, so -180 to 90. And then the only bit that I used with experience was to rewrite this as f of x equals g of x, because it's much easier to understand when they are equal than to try and interpret when is the difference 0. Now that's a much harder question, but if you've got that, I think you feel pretty chuffed. Okay, last question of the day. So 6.4, I want you to just read that before I come along. And I want to ask you, sine of 90 minus x, what could you write the sine of 90 minus x as instead of the sine of 90 minus x from your other knowledge of trigonometry? What could you write the sine of 90 minus x? You could write it as cos x. Yeah, cos x. So you are wanting to know, when is cos x greater than g of x? But in the actual question, cos x is just f of x. So what it's really saying is, when is f of x greater than g of x? When is yellow above green? Oh, when is yellow above green? Let me put that in. So I go to my thing here and I say, look, yellow is below green over here. It's equal to green over here, but then yellow is above. So I'm going to say, from when x is greater than 150, minus 150, yellow is above, yellow is above, yellow is above. And until x gets to 30, yellow is still above. And then yellow goes below green. And so the correct answer will be minus 150. X is between minus 150 and 30. The real key, and these are like much, much harder questions, and I understand for a lot of you that will be very tough. But really, it's recognizing that the sine of 90 minus x is cos x, and then recognizing cos x is really the same as the function f over here.